Now we are further moving ahead. The new topic, which is the isothermal transformation diagram. Isothermal is what? It is basically having the phase changes. Wherever you see the isothermal transformation means the phase changes, because isothermal means the temperature remains constant. And while you are having the temperature constant, it means you are not raising the temperature. Neither you are raising nor decreasing the temperature, though you are supplying the heat. So where that heat goes? It goes to the making transformation of that material. So phase changes occurs, and phase changes must be of two kinds. I mean, it could be either the liquid, solid, gas, and they are the plasma. So these four states are there. It can convert one to another. But another one is they can change their phase of crystal structures. Suppose it was earlier it BCC, now it got into the FCC. So the crystal structure changes is also known as the phase changes. So here the isothermal transformation diagrams for the FEC means the iron carbon alloys and microstructure of development. So the isothermally transformation diagram means where the phase changes occurs and of the material, which is material of the alloys of iron carbon, which is steel, okay, and how their microstructures develop, that we are going to see in this topic. Okay, so isothermal transformation is known as TTT. Okay, diagram also known as time temperature transformation. That's why it's known as TTT. Three times three means first one for the time, then temperature and transformation. Time, temperature, transformations. Diagram and commonly known as isothermal transformations (TTT) are critical tools in understanding the phase transformations that occurs in iron carbon alloys during heat treatment. Okay, these diagrams provides information about the transformations of the austenite into the various microstructures such as the pearlite, bainite, and martensite at a constant temperatures. Why they are at a constant temperature? Because the phase changes, whenever the phase changes occur, the temperature remains the constant. Otherwise, the phase changes will never occur. Wherever you are seeing the phase changes occur, that must be having a constant temperatures. Okay, they are essential for designing heat treatment process to achieve the desired mechanical properties. Okay, here's the diagram. Here you can see this is the temperature, temperature on a y-axis, and on x-axis we are having time. So here we can see, how at a different temperature and at a different time we are having a different, um, you know, different uh, crystal structure of iron carbon and steel. Okay, here you can see austenite, here austenite plus bainite, here austenite plus pearlite, here complete pearlite, here only bainite, right? Depends at what temperature and at what time that you are having, right? If you are just at the same time at the same temperature, but before, you are just here in this time, then you are having only austenite plus bainite. But if you have crossed the time, now you have just crossed this particular this line, if you can say, at a 600 degrees C, sorry, 600, here the temperature has been taken into Fahrenheit. To just be clear about the temperature unit. Okay, so what unit, you are studying right now, we have taken the diagram which have taken the Fahrenheit as a temperature scale. Okay, so you must be seeing the different kind of the graph where you would be having in the centigrade, sometimes you will be having in a Kelvin. So you must be having a different temperature values, because the temperature will be the same, but the temperature scales, due to the different scales, you must be having the different numbers, right? So here 600, you would be having this, this particular time, okay, at which the transformation will occur, and you would be having only the bainite after that, right? So this is a critical time. After that, at for this particular temperature, right, the transformation will occur, and it will be changes into bainite. But for that, okay, here you can see, okay, so for the different kind of temperature, for different temperature values, you are having a different crystal structures of steel, okay, at a different temperature time as well. This is also same, but here we have taken the temperature in a centigrade. Okay, so you can see the different temperature measurement you will be having, but overall you would have the same temperature, because it doesn't matter. If 20 degree would be the 20 degree, right? Whether you are measuring in a Fahrenheit, then you would be having a 20 degree centigrade into the higher numbers. The numbers will be changed, but their significant value would be the same. Okay, the same kind of the diagram here. You're getting AF plus C. A means what? Here A is austenite, F is what? Ferrite, C is cementite. Okay, so here A plus M. Here only A we are getting. These all are just a different um, you know uh, uh, isothermal transformation diagram of what? Of steel, right? Time in seconds. So here the time here 0.1 second, 1 second, 10 seconds, 100 seconds, and 1000 seconds, and so on, right?